Something on last night. Cook. Okay. How are you right now? Jadi, you introduction mental mindset.
This I think this one, and that one. Then one sounds.
I'm going to do that for the system.
I do this data.
It's been straight with it.
And then it's really anyone.
Because
The conclusion.
Apa? Yeah, it is being live streamed. Oh no! Of course it is being live streamed. What do you expect? Ah! I have not just
Don't worry, today, me, myself, and
Michael and
Should I go through this?
we'll be talking about our research paper, which will talk about the effect of the red card on the win rate in a football match. So just a little introduction. Football is a game with rules, and with rules, there's consequences that fall on these rules. So a big rule that can be broken in game is when a player does a foul, and if severely fouled twice, maybe 2 yellow cards, they will be given a red card, and this will suspend that player for the rest of the game. As you can see, that could be very detrimental to a game, and that's why us as a group thought it was an interesting idea to see the effects of a red card in game. So when you look at the game, when there's one less player, the removal of that player can, in a wider scope, can actually make or defeat that game, where that accumulated number can be called away. Scary. Cool.
yeah.
So these are, like I said, source. So we actually got our source from a Kaggle Profile.com, where this person actually was, his name is Sebastian Dybala, where he was able to web scrape from a website called Live Sports, where it hosts a lot of football and it has a big data set of games. As you can see, it has around, what was it, 96,000, and includes all the major leagues like the League, La Liga, Liga 1, and many more. So, so the hypothesis.
I'll quickly read the hypothesis. So this is the hypothesis we have for this project. Our hypothesis is that the red card given the match will have no effect towards the win rate of the team. Now we propose an alternate hypothesis that if a team receives a red card, it will negatively affect the win rate. More on this later towards the end of the presentation.
Okay, before we get into the details, I will like to explain some of the machine learning techniques that we use to produce SEMs for Big Machine, Random Forest, and Data Sniper. And the other two are logistic regression and XP classifier boost. But after testing all of them, the highest one was K-nearest neighbor. Minus the evaluation methods, we use these to evaluate the machine learning techniques. Mostly we use accuracy more than any of the other ones because accuracy is measured overall, so it's pretty much the best way to say that machine learning is good or bad. So, and then as I said before, K-nearest neighbor had the highest score rate compared to the other. Averagely, it had higher averages than other machine learning algorithms. Most of them were 69 or below, but K-nearest neighbor had some of the highest ones, with this one being 70 example. But this is for the home team goal, while the away team goal is actually 75% above. But that's the data when we execute on that side. But we did reach 75% accuracy rate in on goal away. So instead of to complement our hypothesis, I did a result test where I used K-nearest neighbor as a way to predict whether or not what would happen within a game. So in S45 basically means that I took a game that didn't have a red card to begin with, and then compiled them. This is the after the red card. This is the average amount of goals after the red card on average. But to truly test the hypothesis that we made a predicted 45 data frame that was a predicted model of the before goals and goal away and goal homes, and then we predicted it. The surprising result was that goal home had on average 0 scores, which proves the hypothesis that the red card greatly heavily affects to the point where nearly 0%, there's a near 0% win rate on the affected red card team. The conclusion was that the red card affects everyone's scores, of course. There got 0. And then for the model, K-man had the highest the highest accuracy when it was K35. I checked up until 100, so I'm pretty sure that's probably the highest, and it was averaging out near 50.
Alright, so real quick on the hypothesis conclusion, we form a hypothesis test using paired t-test because we're trying to compare the two variables, which is the goals before and goals after the red card. So that's why we use the paired t-test, and the result of which is that we get a statistic of 17.65 and a p-value of 6.65 times 10 to the power of minus 57, basically a very, very small p-value, which shows that we can reject the null hypothesis, which shows that yes, there is an effect. The red card does have an effect towards the win rate. And this is a visualization of our hypothesis test. As you can see that before the record, this from all the matches that from all the matches in our data set, it's about 1.5 goals, and then it increased to somewhere around just under 1 goal per match. And that is it. That's it for the measure.
Yeah, okay. But total after record, okay, that's okay. But yeah, just comparing that, maybe it's not really level of the data. Usually record maybe happen in 70 minutes, 80 minutes. So you compare 80 minutes
Okay.
to 10 minutes, it will average goal is of course different. So most of the time, yeah. So I think based on data, if possible, you can show the data when the player get the red card and the graphic. So then you can compare like this. If not, this is not really correct.
Maybe we want to go into the actual code because we did have that, but we didn't use it for the hypothesis visualization. But we didn't average it out. But it did exist around here where M0 there means minute 0. So for each minute there is a certain action. But mostly for Ryan, do you still have the original one? We don't have the original one anymore. When we did it a few 3 weeks back, we did your visualization of this a graph to show where red cards usually are. The spike was around 48 right, last time. 48? It was like
Usually second half.
yeah. It was after second half. Rahan will try to find the graph, but we didn't have the graph at some point. This is just shows the.
You can put it like on. So, other than you showed that home and away previously. Home and away the data.
There are multiple data that show that.
But it always can be seen in both ways, right?
Wait, no, this is mobile training. This is pre-processing. No,
I mean the slide that you showed.
Oh, which one?
Oh, this one.
This one?
Go home is maybe the thing that in the
It's a home team.
home team.
So how the data was structured was home basically means
who's got the red card?
okay. In this one, I just made it so that the home team gets the red cards all the time. Because this is a predicted one. So I could randomize it, but I wanted to see the pure effects of a red card based on the predicted model that I made with the KNN. So
Okay.
We discussed a lot, then I still don't get it then. What are the features? What are the features?
What are the features?
So it's go home.
Yeah, show me the features.
Oh, the new one. Yeah, the new one. Wait. We did add new features to increase the accuracy. No, this one. No, we removed that one. No, this is no, this one. Then this one. Okay. So what I did to increase the accuracy was, so I removed. Since early on we had yellow card, red card, and own goal. When the data became, I thought it became super cluttered and it became too hard for the machine to understand what we were trying to project. So instead, I went for I added all the own goals into their own scores. So goal home has an increase from own away, and then own home got increased to goal away. And then the red card, since I knew that I already dropped all the data that had more than one red card and then had 0 red cards, I knew that all the red cards were only one red card per game. So I just merged them into one column. This is red card. So if it's 1, it will be home, and if it's 0, it will be away. In this particular one, I just made them all 1 so that they even predict home, go home. And then score rate is a new data that I made based on. So I'm still using classification for this only because regression doesn't work because goals cannot be decimals. they have to be normal numbers. So I thought it would be better for me to just use classification instead. So I use classification, and then because if I use the normal score rate, the actual number, it will show too much variance, and then it would destroy all the predictions because I'm still using classification. So instead, I classified all the score rates based on the amount they were. I might want to scroll up it's here. So the score rate is based on if it's 0.01, it will be 1 and 0.01 and 2 and which is 0.05 and if it is 0.05 and 6. How I got this number was because I went to the game, the INC game with all the minutes, and then I went to the red card. I went to the red card. I split it on the red card, and then I totaled up all the goals, and then divided by the minute to get the score rate. And then I just put it into the data and see if it increases the probability or not. Based on testing, removing yellow increased it by 1%. Very minuscule. But it was also very minuscule because removing own goal, 1%. Removing yellow and yellow away, yellow home, 1%. And then adding and making the red card one column, 2%. And then after that, after adding the score rate, it increased by 32%. And the final was 70% for goal home predictions, and then for goal away was 76.
Only the goal away is that's the best.
Oh yeah, I was in a hurry. I was very I was like, oh. So I was in a hurry. I can just switch it up right now, so I can just change the goal home, the red card is goal away, and check the data again. It might break the machine.
The thing is, if you say it's improved by 1%, 2%, I think it's just by chance. If you repeat the experiment like 3 times, 4 times, it always goes up and down, right? The accuracy is not always that number. It always goes up and down.
That really depends on, since I tested with multiple machine learning supervised machine learning algorithms, they all increase by the same percent every single one, which is, I thought was interesting because when I went to individually all of them, they increased all by, when one increased by 1%, the others increased by at least 1 or 2.
That's why it is statistics. You cannot claim it increase 1% because you look at 1% number, but it doesn't with the statistic whether it's really significant increase or not. It's like if you try like 10 times, 20 times, and then the accuracy is consistent in that number, it's always higher than the other number. You test it with the statistic and you get a p value very low, then we can conclude that yes, it's improved because of its so. But if you just guess it, oh, I see like 4 times I see it's increased, 3 times I see it's constant. It's difficult to make the conclusion. 70, I think it's fine. 75, it's reasonable. The best, around 80, 85, I think is the best one. But if we can get that one, I think 75 is fine. The problem with the data, I think, because there are so many zeros. I don't know how you modify the data. We can merge and do something like this. Or maybe you can normalize the data.
Normalize the data, this way called, I would say, it become decimals. That's okay. But if I go with decimals, then I just square up the decimal numbers.
Square doesn't change zero.
And it predicts, sometimes it predicts decimal, that's why I use classification. And it's
So how do you avoid regression?
because if it predicts decimals, goals cannot be decimals, because of the one.
You can make a classification like this one.
Yes, this is classification.
Yeah, I mean, the problem is the features has a lot of zeros. That's why the machine learning cannot capture correctly the pattern. Not with the label is fine. You can either use regression or classification. government, why it's hard, why you just stuck in 60, 70, I think because so many people that they cannot really see the pattern. I mean, if you, I know that you have the hypothesis that the goal will be affected by the red card, but if it's not shown in the data, I don't think you need to push the machine learning model to find that. Maybe you can change your perspective a little bit.
I want to maybe try to predict win rate and win or loss instead of I thought with predicting goal and goal, yeah, I'd be able to just get that. It's predicting goal and goal because I just find the on reaching.
What happened win and loss?
Win and loss. Yeah, because I thought with goal and goal, yeah, I could just get win or loss by just negative average next. So I can do it. So considering if the percentage is so low, I can just add win or loss as a prediction because it's a lot easier for the machine to do it. That's all. Thank you. Yes, well, of course. Miss, about the research paper, it's the.
You can still, if you have the draft, I will have the.
Okay. Yeah.
Just submit it to the link.
Okay.
Thank you, miss. Thank you, sir. Thank you.
Miss, can I use Speedo as well to presentate the data? Okay. Okay. Ready?
So, in our project focuses on the efficient aspect of modern business, which is to increase the efficiency of target advertising. And we are partnered with Factor Rooms Initiative at Yale Science, in which we try to harness the power of data science and statistics to actually improve the efficiency of target advertising, ultimately business growth. So, target advertising interests in understanding online consumer behavior. It's about sending the right message to the right person at the right time. And our approach is to use behavioral insights in order to do ads engagement so that we're able to help Lumos types other consultants to be able to do their work. So this is our hypothesis. We have two hypotheses, which is the null hypothesis and the alternative hypothesis. So the null hypothesis, but when we compare two different ad nets or advertising networks, for example, FMB or Marvel, we're going to show that they have the same influence in revenue generation, as well as if we compare it with all of the ad nets, they're going to show that they have a uniform generation. And for alternative hypothesis, it's the opposite, where it's going to show that they don't have an equal amount of revenue generation. They also have the same amount of revenue generation.
So after we decide our hypothesis,
Of course, we have four methods that we are going to use. First of all, we are going to use t-test and t-test. We're going to compare what in groups to find the significant difference. And also, my technique is to find the significant difference about, to find that the data is not distributed or, to find the data is distributed or not. And lastly, we are also use ANOVA to determine the differences between three or more, and yeah.
So for purposing, we split the data frame into four steps. The first one is we reverse the data and drop the units columns or the values. Then we so that gives when we're doing the conversion and verification, actually clean and string data. And last one we're doing our revenue conversions and marking up since Ms. Doro recommended us to convert the revenue into USD. So the RMS value does not become too high. The British license, these are our features. First one is status. Status will show the behavior of users surface, and it will show the user engagement levels. The next one is AdNet. So we're using advertisement network. So it will attract people to purchase their services. Next one is data targeting. More data targeting will increase the chance to get more revenue. Successfully, this column will be dependent with the targeting. The last one is cycle. It will show the duration of the subscription cycle.
So we created the visualization in order for us to be able to actually see the So the first one is a bar graph which shows the distribution of users based on market. As you can see here, Miles has the most amount of user and Philippines has the most amount of user. But this is the distribution of the status of subscribers of Lumos Hive app, whereas as you can see, 82.4% are active users, 4.7% are inactive users, and that's what we is 0.1%. And for this one, this is the box of revenue for archive. As you can see, it can show the upper bound is around 11, the lower bound is around 0.5, and the mean is can be seen because as you can see,
And this is the most used method. As you can see here, Marco has the most method that user use, followed with the vanity, and the lowest is the active stuff. And here is the subscription status distribution country, where status has three levels: inactive, active, and error state. And Laos has the most active subscription status, followed by Oman, but Oman has also the highest error state followed with Laos. And where Thailand also has the most inactive followed with Philippines and Indonesia. And this is the subdivision, and it goes criminal cost per country. Where again, Laos and Oman has the highest subscription and renewals, followed with Thailand, Indonesia, and Philippines. And this is the revenue contribution to AdNet, where the country has the highest contribution of revenue, where it has 52.7%, for Turkey with 33.2%, and the Morocco has the lowest revenue contribution with 0%.
so this is the models of targeting that we use. So we use from 11, we use 6 for standard models, and we use 5 conversely. Again, inverse the regression SCR, and for the regressor, and for personal regressor, active boost, cut boost, area boost, and golden boost. Why would we use boosting models? Because boosting algorithms takes to improve the prediction power by training a sequence of the models. And we also use the tuning so that we can increase the efficiency of the algorithm.
And this is the result of the hyperthermal tuning that we did. The real results. So this is the first 6 of our model results, where Random Forest has the highest RQ score, but also SVR has the highest RMSE.
and then the regression as the lowest after food. And this is the last 5 of the model, where CatBoost has the highest R2 score and IGBM has the lowest Rubin square. Also, XGBoost replacer, the same as SVR. It has the highest parameters. And overall, CatBoost is the most efficient models for our data.
So we're going to discuss about the feature importance for the for three algorithms. First of all, the decision tree and CatBoost has different feature importance, with different feature importance.
Very persistent. If you want to write into a virtual
Oh, yeah. So here, the success feeling is basically the first, and then the second, also the third. However, in the here, we find the difference between what is that cycle and status. Makes difference that here, cycle is basically 4. However, in here, status is basically 4. So it's swap. However, for the light GPM, however, we compare another very boosted, light GPM feature purpose, and we found that the cycle and is basically 4. So probably, so then we concluded that the feature inverters are more reliable in this. Next. So here's the correlation matrix that we have. First of all, this actually empowers our validation in choosing the features. And when we choose the features, there are 5 criteria: success rate, content charging, status, cycle, and also the ADNAT. And it turns out that success rate has the most correlation, and which is followed by content charging, and then which is here, and then followed by status and ADNAT, and lastly the cycle. So it really empowers our correlation in choosing the features. So let's move on to the hypothesis. So first of all, the first hypothesis that we make, we want to measure the group of ADNAT, and what average revenue group of ADNAT that has a difference or not. Okay, this is the low hypothesis that we're going to measure two different ADNAT, which is market and also the revenue average, and also there are the name, which means that the opposite of the That's so how do we get the sample? So we're going to use second sample using the random state of 42. So we're not going to use the first 5 or the last 5 of the data. Okay, next. So this is the t-test. We have counted manually and also using the title, and it turns out that the fifth size has the lowest statistic, and then the 30 size and the largest size has the largest statistics, which means that the p-value for the t-statistic 1.49 doesn't meet the requirements of the significance of confidence. Oh yeah, I forgot to tell that our significance confidence is 0.05. So if the p-value is so if the p-value is higher than the 0.05, it means that it failed to reject. And also, when we test in the 10 sample, it seems that the p-value is decreasing, except for this one. Very probably it's because of the delta. And yeah, almost all of them are decreasing when connects. So when we use the z-test, and it improves more. And also this will prove that t-test and z-test is different. When we use t-test, the p-value is 0.09, and also the p-value for z-test is 0.04, even though they have both have both t-statistic and z-statistic are the same. However, the p-value are different. This determines that z-test and t-test cannot, the t-test should be under 30, and also the z-test should be more than 30. Should be more than 30. So in this case, z-test is best to use in the z-test in 30 sample sorry, 30 sample is best to use in the 30 sample in this class. Next. Okay, the next hypothesis that we are going to discuss is about the distribution of each of Marford and also FND revenue. So here, to check the distribution of every sample, we need to use the Mann-Whitney test. So the Mann-Whitney test will use the sum of rank and also the sample size to determine the statistic. And here we can see that it only requires 5 sample size to reject the null hypothesis. And here it shows that the p-value is decreasing when the sample size getting larger. And this means that when I do the 50 more sample sizes, that it means that the p-value will be decreasing further. Yes. So the third hypothesis, which means that we are going to compare, every AdNet in every average revenue AdNet. Here, there are about 72 AdNet, which is a lot, and usually ANOVA uses 3 or more groups. But here we are going to use 72 AdNet, or we can solve groups. And of course, the null hypothesis, we are going to check if there is no significant difference from all of these AdNet. Okay. Here, we have tested the ANOVA F statistic. We found that ANOVA F statistic has very high value, which is 187, which the Python cannot determine the p-value, which is 0.0, which is considered. It can reject the null hypothesis.
So you compare with
This one is everywhere and every AdNet. No, for the first and the second hypothesis, we compare AdNet or also FND. But this time we are mistake that to support our statistic in the paper, we can compare every combination of the AdNet, and we show every combination of the AdNet. Yes, I got everything same. Everything are same. But here, the p-value, we cannot determine the p-value since, the Python shows that the p-value is 0.0, which is not enough evidence for reject the null hypothesis. Therefore, we are going to use post-hoc test to check the result further. Here the post-hoc test, we're using the two-piece post-hoc test to check every combination pair of the AdNet. And here we can see the p-value here, and also how do they reject the hypothesis. What hypothesis does this mean? That we are going to do the first hypothesis, which is the rejecting the average, which means the average revenue on 2 AdNet. Okay, here you can see that in every AdNet we found that there are 2,485 2,485 combination. That's it. And here, this is we have used top 10 to 25 and free AdNet that ANOVA has the largest statistic, and also the every AdNet we choose should be the lowest. Here, the top 10 AdNet only has 24 combination, top 25 has 200 combination, and every AdNet has 2,485 combination. So to visualize this p-value on each combination, here 0 means that the blue cell means that it rejects the hypothesis, while the red one means that it failed to reject the hypothesis. And it can be seen that the blue one is there is more blue cells than the red cells, which means that it rejects more than it's found to reject. Next. Okay. Yeah, after that, but I'm gonna conclude it all. But every add that we choose, that almost 80% of the combination has felt the reject. Here, the rejected, and there is only a small portion that can be rejected. The null hypothesis is.
So basically, this is our conclusion, which is that success billing and advertising at net is the this most important driver of revenue, and the CatBoost regressor is the gives them best result as they have the lowest RMSE and the highest R-square scores. And for the test, it shows that and choosing AdNet is significant because they show different revenue generation as you can see from Marvel and FMD, whereas Marvel is used more frequently, but FMD generates more revenue. Thank you.
That's it for our presentation.
I just want to make sure, you need to know what is the unique solution from you, because the other group also do the same. So I want you to make sure in the report and paper what is the unique finding or insight that you can find from your model and your class, because you have a lot of success. I want to see it in the report.
For the other so because we are trying to produce open
We are out of time, so I'm taking the paper in the report. Instead of discussing about the machine learning model, I want to see the insight from the data.
Dan tadi yang terjadi di luar negeri, hanya terus sama di kemarin juga.
You have 20 pictures. That's it only for the
So, good morning everyone. For starters, today we're going to present about our project regarding the data science and statistics. Next. Okay, so for both statistics and data science, we use data set provided by a company named Site. And then the data set that we choose is named subscription. Later will be described. Next.
So first, before we make the data model, and then we process the data first. So first of all, we change the embedded data type, since all of the data from the website is in object data type. So we change them to their suitable data types. And also we drop relevant columns and rows which we feel like doesn't meet our goals. And then we also do currency conversion, since in the data set there's a lot of countries and then the currency in their respective country, so we change it into Indonesian rupiah. And finally, we did a time extraction list just for the one specific column called the answer date, which we use in our data set, and which we did extract the hours and then the year, and then we put it into a new column.
For just a quick review, this is the
the columns that inside the subscription data sets. So there are 26 attributes, as you can see here. And then after mapping the data, we only use only 7 attributes, which is aligned with our project regarding the subscription, which is on the cycle config revenue subsidy service correspondence.
So we now move on to data visualization, which we use to calculate our project. So the first one is the subscription duration. Since we are analyzing declining customer engagement, we created a visualization that shows like how for each country the duration of each subscription in days. And then we also created the active user count starting from 2022 until 2023. And also we make a revenue, like total revenue generated for each month.
Okay, so this is the average for service price for each month. As you can see, LA, which represents Laos, has the highest service price relatively. Then Oman has around 1 million, and Senegal has 3,000, and Iran is around 2,600.
3 million.
Yeah.
Yeah, that's why we created into a table since.
Actually, what to ask, like, which convention should we use?
No.
The symbol.
The symbol.
The comma and dot.
Yeah.
The comma, yeah.
Oh yeah.
3,000 or
Yes,
5,000?
so
3 million. Sorry. Oh.
So next. So here is the revenue generated. So this is loss. This is around 6,004. Oman around 6 million. Senegal, which has done 3.25 Thailand, or everything.
Dah. Wait. Sorry.
Okay, so this learning model that we use, so there are 5 learning models. First is the learning part together. Second is functional model. Third is the use, fourth is the CR, and lastly, decision tree regression. So the parameters that we are using for our part is there are other an estimator, or you should say the tree. So this question model layer, so provider, and then these are the layer before we are converting to one output. So this is the result from our model. So this first one is the correlation matrix, as you can see.
Oops, sorry.
Has around 1.0.9, and with correlated Thailand. This means that eventually SMS and Thailand are both linked, but by that name, I mean it's they usually pair together and work and Thailand as well. This is the source of the subscription. So what I know from this business is basically people can request like the charge subscription from these sources to via SMS or to website, USB, and so on. So this is the feature importance for the top 5 most important on 3 separate model. And as you can see, SMS has the highest feature importance on 3 model, and followed by service price converted, and then revenue converted. While OM and web has basically negligible amount of importance.
I was supposed to change the table. It's not really easy to find the 0, 0, 0, 0, 0, which one is greater. I cannot see the number clearly, so I just change it into like the bullet point.
So for the next one, we took a sample for the data that we have sampled. We test it for 10 times, and then these are the predicted value
that we predict, and then this is the true value that we predict. So first one is 16, second one 32, and then so on, 85, 31, and then the worst, and then this is quite a lot difference between the predicted value and also the value. And then the 31, 1, 45, 32, and 394. So this one is like the quite a for this one. Next. And then for the error methods, we use the mean absolute error and square error. And then for the 5 models that we choose, we have random forest, ADA, sequential, and decision tree. And then for the first one, we have the random forest for both AE and RMSE have the highest, which is the best out of 5. And then the second one is the AE plus, and then followed with sequential, and also decision tree. And then for the SVR, for both MAE and RMSE has the worst one. Next. So what the conclusion of this error matrix, random forest and decision tree are the best problem as the best model for this problem. Since both MAE and RMSE got the highest possible relativity scores, and then ADABus and also sequential model can be the alternatives. And then for the lowest one is the SVR, since it has the non-relativity scores. Next.
So for our statistic project, we decided to create a different problem for than the data set. So for the hypothesis, the null hypothesis says that the average revenue for a Mantel operator in 2022 is the same as the average revenue in 2023. Then the alternative hypothesis says that the average revenue for a Mantel operator is different compared to the preceding year. So we did 2 tests. So the first one here is the t-test. Here's we did a 2-way t-test, and then here's the sample number, and then here's the mean and standard deviation. So we use the formula and then get the t statistic value here, and then the t value here. And since the t statistic value is within the t value range, we can safely conclude that we failed to reject the null hypothesis. Then other than t-test, we also did the z-test. So here's the formula. So the z value is 1.96, and then the z value is this. So in conclusion, the result from our t-test shows that the t statistic value, as mentioned before, is in between the p value with the significance level of 0.05, which means that we failed to reject the null hypothesis, and this also means that the average revenue for a Mantel operator in 2022 is the same as the one in 2023.
I think it's all for the Mantel conditions.
A Mantel operator.
Just one, you can compare the others.
Since the valuenya.
So it is
For 2022, how many months?
12 months.
For 2023, also 12 months.
I think it was
Cuma
10 months.
excuse me,
So it's not really safe.
ada sampel saja.
Sorry, in 12 months, when they got the most revenue, in which month?
I think we should take the hypothesis.
We actually check for the whole year rather than in months.
Now, if you said 2022, 12 months, 2023, 10 months. If you miss 2 months, and then that 2 months is the most, usually the most revenue, so it's not really valid. Okay, just make sure you look when you explain it.
Okay. So that's it for our presentation.
Thank you.
Do you want to run it? So this is basically the import one, and then we go to the data loading part, which basically takes the subscription mix data. Afterwards, this is the part where we are starting to reassign the data type to the suitable types. After this, we start to process a bit. So first we drop the unrelated column, and then we get rid of invalid data such as cycle equivalent, which basically, since we'll take a look on the documentation and it doesn't have any explanation regarding cycle equivalent, so we just remove it. And the subscription, the substate and unsubstate, basically we just drop when the unsubstate happened before the subscription date, which doesn't make sense. And then lastly, we drop a row which has a higher success billing attempt than the attempt charging itself. So model. Why is the duration of the subscription index?
Is there any case where the customer re-subscribe again?
I don't think there is, but I think they like separate the row.
So in one row is always one subs.
Yeah.
And then the lowest RMS is?
The SPR.
Yeah, how much?
Around 45, 43.
45, 43, what is the longest? What is the longest delta date?
Di atas kan tadi nih. Iya tadi. 152.
So it's around 80% then. 80% correct, right?
Yeah.
And the R-square is 80.
Oh, we don't use R-square. We use
RMS. Yeah, try with R-square. Because RMS is the error rate, right? With 100, your model can do mistake for 20 days. I want to see the R-square, and then what is the feature that it is?
Okay, so
Also, to make it easier, you can just use 2 significant digits for all the number. The other one will have 3, the other one just 1. We can use 2 or 1 for all the number, and use the same symbol with the dot.
So the feature that we're using is the converted revenue and converted to price, which basically revenue in rupiah and risk was in rupiah. And then we also use country, source, and cycle. You only one encoding form.
There are 5 features.
Yeah.
If you write the reason why you choose only 5 features, okay, please write that in the report. It should be based on something. You cannot just guess. It should be based on the reference. On the specific conversation, is it the same pattern happened in the same country, in every country, or I don't know, probably in Oman is different than in Southeast Asia.
Datanya itu nggak sih, negaranya cuma yang ada di situ doang nggak sih? Nggak semua negara.
So I think it's different for each country.
So what is the insight after you run the machine learning model? What is the insight? What is the conclusion? I mean, you have the highest, the loyal customer, right? You can find. So what is the insight?
Yeah, so basically, quick introduction. We use this learning model to predict the user which subscribed at 2023, the beginning of September to 2023, the beginning of October, and we found that the mean of the predicted value is around 43 days, with the maximum value of 153 days, and then the majority of the user actually has only 5 days subscription.
So, what does it mean?
So it means that the customer engagement actually might be declining.
Lower this year.
Yeah.
Last year.
Last year, I mean, the bigger.
I want to see that as well.
Yeah.
Not only this one is perform better than this one. There are lots of people that doing that. Yeah. So I want to see the uniqueness of the finding in your work.
So we put it in the conclusion. Yeah, this could be one analysis.
The one that people can just see from the visualization. Okay, that's all.
Itu bukannya dari paper ya?
Oh, is that clear?
Iya. After this
You filled the form, the form.
Oh, yeah.
already.
Can you come to our
All the things.
Oh, very good.
Itu kan ada kan? Yang insight-nya ada di paper. Dapat di
Oh, no. Yes, very good. Okay.
ada yang ini. Kemana? Bisa? Sini. Enggak. Dari awal ini dari start from the Visual Studio Code. Oh yang ini dah. Itu introduction first. So you can start. Today we're going to be doing a presentation regarding our project about creating a data model that shows the declining engagement of customers using homozygous data set. So,
Orders are going to be explaining about libraries, drivers, uses, and the keyboard and the rest here. So the step that we do for this project, first of all, is going to be the data processing and waiting.
so pretty much this is already the merge data set. There's a total of 3 data sets that were given by Mozart itself. 2 subscriptions and 1 transaction. So beforehand, what we actually did was that we ended up merging the original subscriptions mix and the additional subscriptions to create a better what is it called? Data set. So now let's move on again. So if you were to look at what we have processed, so in the beginning we basically check all of the info for like the data set so that we get to know what the data is all about. So in this case, there's a total of 26 different columns and they all have different data types and features. So after that, what we decide to do is to check all null values in the dataset itself, so that we can get to know how evasive the null value data are and affecting our analysis of declining customer engagement. So after this, we just drop all of like the unnecessary features that we didn't use, such as ID created at Pixel, browser, handset, MSSDN, and TRXIDN publisher. And so basically, we basically have cleaned the data set so that it only shows more, so that it drops like the success billing that is bigger than the time charging, and substate that is bigger than on substate as an outlier. So after that, we just did some more cleaning, and we can continue to go.
And then checking again
No values.
And then
we wanted to actually know how the data looked like, so what we did was we checked for all unique values inside the sources, a feature that we might use. So we just view like the value counts of source itself, and in the dataset itself, there are some inconsistencies where there are like uppercase operators or values, and we ended up cleaning it using fill-NA and replaced by pandas. So we basically rinse and repeat the entire process until we get to this part. So in the currency itself, it's been shown that there's like a lot of null values, and we wanted to fill those currencies so that we can determine the correct revenue that is converted. So what we ended up doing was replacing it with the correct spelling, and based on the country currency, we fill the currency subset, and after that, we view the revenue and service prices for any different. Sorry. So there are like a lot of values. So I think let's just move on to the important stuff. So in this case, we did some data reformatting where we convert all of the time charging.
Yeah, you can skip this.
Can I just skip to the EDA, miss? Okay. So basically what we did for EDA was we view like the trends of the revenue based on the charging date. So in this case, it is shown that there's a decline between month 7 and month 8 in the charging date of transactions, while for the subscriptions, it's a constant increase and decrease between month 4 and month 10.
The first one is what?
This is the charging date, miss. In the transaction, there's a feature called charging date rate. So we just plot the revenue against the charging date itself. And then we view the
charge the user.
There's days where the customers get charged, and then we plot it against the revenue to see if there's going to be some decline over the months.
Then the other one?
this is just this for the subscription data set.
Yeah, I don't talk about the data set. I want to see why the other one has a declining during 6 and 8. The other one has an increase during the end of the year. What does it mean?
So Basically, it means that in the subscriptional data set that between month 6 and 8, there's more activity in the transaction itself. So that's why it has an increase as opposed to the charging date where it's a decrease. More successful billings are happening.
But why the revenue is going to increase?
For subscription fees? What we checked is that the peak monthly revenue was 800. Which one was?
Between 6 and 8.
Oh.
The revenue is 0, right?
Oh yeah, sorry. It's sorry, not an increase, a decrease in activity because the revenue itself is decreasing. And so from month 9 and 10, it has a constant increase and then it drops again in 12. So we can explain the success billing.
And this is similar like the first one.
Yeah. Just like the monthly average charging attempts, so from the bar plot itself, it's shown that between month 6 and month 7, it has like the highest average charging attempts. So we then view how many unsubscriptions are there. So basically from month 6 and month 8, as opposed to the revenue, there's a lot of unsubscriptions which causes a decrease in revenue.
Yeah, this is also still in line with the first
Yeah. It's the profile status. So I think let's just move on to the data models.
So basically, we extracted the important features from the original dataset and put it in the new data frame. So because our main goal is to show declining customer engagement, so our target variable is
declining, which is based on the status itself. Where
so the update is different and start with capital letter and start small, and then we start with the number.
Yeah.
Have you changed that thing?
I haven't.
So they treat as different update.
Yes, miss. Later I'll clean it again for better results. So, and basically we just label encoded everything, benefit transform everything from the subs, unsubs, renewal, country, operator, cycle, service, and admin. So
when we go transform the AdNet,
yeah,
it's become different stuff, different AdNet, right? Because they have
yeah,
3 different shapes.
yeah.
Have you confirmed with the
Are
they really means different, or it just typo that we do?
I think it's different admin itself.
it's only like that, so
Yeah.
I don't know, maybe it's the same. You did right?
So for the data model itself, we did random forest classification, and then decision tree, gradient boosting, and then nearest neighbors, and finally naive Bayes. So from the data model that we have done, basically, we found out that the one with like the most consistent score is found in key nearest neighbors, which produces a constant accuracy, precision, recall score, and F1 score. While for the best accuracy and precision, can be found in either decision tree or random forest.
What is the features?
The features are service encoded, AtNet, operator, renewal, subs, unsubs, and revenue. And from the feature importance itself, we find out that service encoded has the most effect basically on the feature importance of the dataset for the target variable, which is declining.
So the subs and unsubs is the date, right?
Yeah.
How do you encode that?
So basically, we basically turned it into months first, and then we encoded it using label encoding.
Just month.
Yeah, just months.
So you just take the month.
So we take the middle value basically instead of years and hours.
Is there any reason why you choose the month?
I think it's more of a middle ground, I think, in comparison to our, if we were to do hourly subs or yearly subs, it would, for yearly subs itself, it would have shown like the long-term effect, while for hourly subs, it will show like the short-term effect. That's why we chose monthly subs. So this is our confusion matrix, and
1,000
3. So we need to improve on that. And this is our curve. So the result for the decision tree, gradient boost, and random forest itself, they all have the same RFC curve, which is of 0.97. So yeah, I think that's about it for our data science project. So for the statistics itself, sir, we conducted a null hypothesis based on the monthly subs and, wait, sorry, not monthly subs, what is this service price? It should have been monthly subs and success billing. So we conduct monthly sub and
Success billing.
so our null hypothesis is success billing is independent of monthly sub.
No correlation.
And no correlation, while the alternative hypothesis is the opposite of it. So
Not take it should also.
So-
Okay, so what happened?
So based on our research on our t-test and z-score, we found out that our t-test and z-test rejects the what's it called? Rejects the null hypothesis because the value itself is kind of like the range, out of the range of the t-statistics table.
So the option only manually sub, no yearly sub.
No, we just we have only experimented with monthly subs actually.
So you have the data for monthly sub,
Yeah, but I also have the data for yearly,
yearly, monthly.
monthly, and hourly. So
So
we
you don't touch yearly?
in this case,
Also success is doesn't.
so
So different like yearly also. You check.
I think what we could do was make a middle ground maybe that
How you compare monthly yearly?
monthly
Yeah, that's okay.
between monthly subs and yearly subs, is it? Oh, okay.
You want.
Uh,
How many type of subscription? Monthly, yearly, only? Weekly?
weekly, we didn't include it in our
No, I mean in the other.
in the data set itself. We didn't include weekly. We haven't done.
Yeah.
No, you need to actually convert it first into like the correct format using so they don't have like a
So this one is real data like monthly.
the monthly subs data.
Yearly also then you have in the.
I already have the data also.
So monthly sum is the number of subscription in that month.
Yeah, basically, yeah. No, basically, no. Monthly subs is the date at which the subscription happens.
Just billing?
Success billing is the number of success billing.
What do you compare between the month and the number of subscription? It's two different value, right?
So they have to pay, right, if they choose monthly or not. So you can compare if they choose monthly, but they pay maybe the next month, you can compare it. So if they pay directly, is prepaid or postpaid?
What, sorry?
Prepaid or postpaid?
This one, the monthly subs.
If they pay first,
It's,
I think success billing should be compared with the other charging.
yeah.
Yeah, it's the number.
I think we could do success billing rate with time charging. That would make more sense.
Monthly subs maybe with monthly and sub. Okay, you need to compare the same value.
Yeah.
From the same, meaning the same.
Meaning the same.
Revenue with revenue. Value with value. Month, I don't know. Month with month, year with year. You cannot compare like year with month. Right? Doesn't make sense.
So that's about it. That's all for the presentation, I guess. Sure. For the box plot itself, I haven't performed it yet. Yeah, in the report itself, sir, I'll include the box plot, the data itself, and I'll make sure it's clean and everything.
okay, let's start.
Okay.
Which call will here?
Don't forget to put in the ability.
Yeah.
Yeah.
Yes, for the report itself.
Next week.
Next week.
Report, right?
No.
The paper. Paper is today.
I will check today.
So when we submit the data, you guys will check it.
Yeah.
You will give notes on how to improve our
I will check how big is the improvement that we can make.
Yeah, just,
I'm going to talk.
Ini ROC gimana?
Sorry. It only says it's not secure. 1 second.
There we go.
Iya, and they will start first. So, yeah, if you want to.
Good morning, thank you for the opportunity given to us to present our project. My name is Ricky Canagdalo, this is my teammate, Luis Banyola, and I'm engineering. For our project, we have decided to create a sort of tsunami prediction. Inside of our presentation, we'll show you our problem analysis, so that it works, our data set and preprocessing, and our models, as well as the techniques we use inside our project. So as the evaluation method and the results and discussions of the group, as well as the conclusion of our testing. Next. For problem analysis, there are emergency warnings. There's a lot of emergency warnings. There are some specifically for tsunami outbreak. But based on our research, most tsunami predictions can only be done at least 5 minutes or around 5 minutes of an earthquake happening. The emergency calculations are just not fast enough to give enough time for as a proper warning system. And it's usually based on only 2 parts: the tectonic movement or the happening earthquake events. In this project, we aim to verify the methods used and the answers regarding the current possible methodologies to predicting tsunamis.
Now, for research studies, after studies for related work, that is similar to our tsunami prediction, but out of the 5, we can listen out the difference between ours and theirs. So the first one actually used analytical and AI model, which we do not use, even though we also created a tsunami prediction. Now, for the second study is that they focus on the credibility of mathematical models that we obviously did not focus on. Now, for the third is that they conduct their studies for near-field tsunamis, that is either offshore tsunamis data or GNSS. Now, we use the data from 1700s, around 1700s from 1751, and they filtered out a lot of tsunami data, while we don't. For the fourth one is that they only use SVM as their machine learning, while we implemented 6 machine learnings like SVM, XGBoost, decision tree, logistic regression, random forest, and others. And the last but not least is that they only use contingent methods as a way to evaluate the result, while we also use F1 scores, accuracy, and others. So for our data set and pre-processing, our data set we get it from the PADA website, and the original data size is around 118.36 kilobytes, and then we drop unnecessary data because, like, as you can see over here, this 1, 2, 3, 4, 5, 6 columns has like a high percentage of null values, which is more than 80%, so we drop them. And also for these two, even though they have small null values, they can still cause an error when we run the testing later on. So we decided to just drop the whole row for this 3%. And then we rename the columns and also create a binary column called tsunami. So this is taken from the validity here. Basically, the validity is like 4 and 3, 3 for probable tsunami and 4 for definite tsunami, but it's hard to see, so I use 0 and 1 instead. And then we encode certain columns like country and location because they are not float. And then so basically the clean data size is 105 kilobytes, and then we also set the features. So basically I skipped this. Can you hit next, please? Our data is not balanced in the first place. Like for the probable tsunami, they only have 64 supports, while the definite tsunami, it has 182 support. So we separate them into the majority and minority class, and then, in the first place, the ratio of the minority and majority is 1:3. So I balance it down till 1:1.8.
Go back.
After we got the clean data, we set the features. For the features, the X, we use basically every column except the country and location, because we already have the encoded ones. The validity, we have the tsunami already, and the tsunami itself, because the tsunami itself is used as the Y. After setting the features, we standardize the data and split it into the training and testing data sets. Next. This is our columns and their description. And here is the event validity classification, but in our data set, we only limit it to probable tsunami and definite tsunami, so we only have 3 and 4. And this is the cause code for our tsunami events, but the majority of them, based on the data, is caused by earthquake.
For our project, we use different variety of multiple libraries to present out to have a better and more concise looking project. And we also have to fix the libraries used are
Is this?
skip.
Yes. This one?
So since we use 6 algorithms, which is SVM, random forest, decision tree, action groups, square linguistics, and also logistic regression. Now, in here, 0 means probable tsunami, and the 1 means definite tsunami. So as you can see, the results are better off in the second one, the definite tsunami, instead of the first one, and the accuracy, the best one out of all is random forest, SGP blues, and also the boosting with 0.85. And the recall is, the best one is random forest with 0.94, and also SGP blues with 0.94. And for the probable tsunami, the recall, the best one is premium boosting. And for the ROC AUC, the highest is still random forest, XP2 boost, and also premium boosting. And lastly is the F1 score for the probable tsunami and also the definite tsunami. The best one is premium boosting for the probable tsunami, and for F1 score for definite tsunami is XP boost and random forest.
So is it more than 1 or 0? Plus 1 or 0?
They're both important. They're both as like 0 is probable tsunami, but 1 is definite.
What do you think it can answer the problem in your research?
Probably 1 because it's definite tsunami.
So just 1. I don't need to put the last 0.
Oh, okay. So this is our stacked ROC AUC graph. I stacked the 6 graph into 1 so we can see clearly. So basically, the more closer they get here, the better they are. So the best model is definitely not BTC, not logistic regression, and not SVM. While the random forest, XG boost, and gradient boosting, they kind of overlap and they have the same value. So those 3 are the best according to the ROC and T's.
By the way, the red looks the same in the power. I don't know, but I know it's Yeah, maybe you can try the difference in both, just change the color into more, different like yellow, orange, the blue, the sky blue.
This is our check value according to SVM. So SVM ranked the year latitude and earthquake magnitude as the top 3. And according to the graph, like a higher value of year can lead to a higher chance of tsunami. And but also the lower value of tsunami magnitude can lead to higher chance of tsunami, according to SVM. This is according to XGBoost. XGBoost ranked year, max water height, and longitude as the top 3. And same with SVM, a higher value of year can lead to a higher chance of tsunami. But this one, a higher value of earthquake magnitude can lead to a higher chance of tsunami as well. Okay, so we actually implemented feature importance to almost all our algorithms, but the best result and the one that makes sense the most is our XGBoost. So this is our feature importance. Now, based on our feature importance, now the most important feature we have is year, cost, and the same importance is the max water height and also the tsunami magnitude. Just take which one is recommended. So this is our Pearson heat map visual correlation. And finally, we're done. So the conclusion is, out of the 6 machine learning, the ones we recommend to use if you have similar data sets to ours is either XGBoost or Random Forest. And we do not recommend logistic regression because it has the worst testing results. Thank you.
Statistic thingy, that accuracy, you don't have to do something.
From the
Okay, we wait, so.
What was the question?
You didn't require an expert.
Yeah, in your discussion, I want to see the insight, yeah, like for example, the one that they explained, the lower the height of the water, the lower the global, something like that. Yeah. We just put it in the bullet points so we can see what the after and also, do you have like geographical plot? Do you have like a visual?
Wanna use yours or the one in your book?
Just the one. Call it again. Go on.
I think it's this one. Shouldn't.
Number 1.
That's it, right?
Yeah, we have 2 maps.
3, I think.
One is interactive map and the other one is like this.
This is also the same, yeah. I have difference in yellow and the light yellow, green and light green is difficult. And make it a little bit different when I see the pattern.
Okay. Yes.
Yes.
Red, what is green? Red tsunami.
I think red is definite tsunami, green is probable tsunami. I believe, yeah, it is. This is, yeah, we should probably change it. This is another one.
This is for the smart magnitude.
And this is our
The earthquake magnitude. That's the
yeah. The majority of earthquakes appear around 7 magnitude.
most are still 7.2.
7.2 and 7.2 is tsunami, no?
Yes.
Dependent tsunami.
I believe so. Yes.
Okay, so I will suggest you another visualization for each magnitude. You can put like the 100% bar chart, you know, the one that's stuck in the chart. Then you have the 2 hours.
Oh,
You can
okay.
put, yeah, the label, then the one is tsunami, in each of these.
You mean to show correlation?
I want to see the percentage of 7.2 is the highest. Is it more tsunami or not? So we can see the trend. The higher the magnitude, the lower, the higher the chance to get the tsunami.
This is the tsunami possible. The majority is coastal earthquake, which is 1.
Now we can see something like this, yeah. It's very clear. It's like dominant in the data set.
Yeah.
You want to see clearly what is this and how does this correlate to the label. And then you can also put the original source of the data, not just mentioning the label. The original source of the data.
The data is sourced from Kaggle that took its source from it's NOAA. It's an American government that it's in.
Thank you, sir.
Waduh.
Kayaknya di rumah. Kayaknya di rumah.
The same place you chose.
Yeah, it's better before, but the deadline is on the date of the exams.
Yuk, sudah bisa masuk di malah tuh good guys. Coba dulu. Wait, I'm turning on my laptop.
Coba ngeliat bisa nggak? Oh bisa.
Bisa.
Ini ya, ada di itu ada di Astrofilm.
Hah?
Ada di Astrofilm.
Gak ada. Wow, there's no respect. I love it.
Good morning, miss. Good morning, sir. My name is Andit, and this is my teammate Andra and Priscilla. We're going to present our project, which is predicting cornmeal for precision agriculture. So technology has revolutionized farming, especially for technology has revolutionized farming throughout the years, and like among all the crops that are grown in the world. Corn is one of the highest producing crops because it covers 13% of the global croplands. For this, we're going to use supervised machine learning to predict the yields based on factors like the year, country, rainfall, pesticides, and fertilizer use. Our research aims to help farmers optimize practices for higher yields and sustainability. And we're going to use 6 machine learning algorithms, and we're going to try to identify each of them and find the best one and find the best one. And we're also going to see the future importance for them too. So the data source. So our main data source comes from ISAC, which is a website by the Food and Agriculture Organization. As the website offers extensive corn yield and pesticide data that are secondary and filtered by county and year and what crops that we want. And the rain and fertilizer data, we sourced it from another website called Our World in Data, which is a website that aims to solve world problems within data. And they said that Our World in Data got their data from Food and Agriculture organization as well. So because we believe that these are reliable sources, we proceeded to do pre-processing. So to obtain the necessary corn yield data, we used filters. We filtered it by all countries, so we selected all the countries that has corn or maize. And then we also selected from the year 2009 to 2019, so around 10 years. Resulting in 1,802 rows and 15 columns. For the pesticide data, we did the same thing. We filtered out by country and by year, getting 2,300 rows and 14 columns. And for the rainfall and fertilizer data, we just downloaded the CSV file from the Our World in Data website.
You want to speak one?
So this is the process.
Yeah.
So this is the data. Each of the cross metrics shows the relationships between the results. You can see in here, it has like the bar is even, not even. You can see the year is in the form. Process approach to be the supplement covers the whole number of the cost of each year.
Why the fertilizer doesn't leave the line? Fertilizer. Fertilizer is one. Yeah. And then yeah.
So you can see on the next one. This is the graph of fertilizer.
That should be one. This should be creating this line. I don't know.
Maybe I'll try to run it again.
So from this graph, you can see that 1 is the maximum, and 0.2 is the minimum. And here you can see that most of this has like little to no correlation with each other. Essentially, the rainfall and yield. The number is 0.34, and yield fertilizer has the most correlation with each other is 0.2.
This means there is correlation.
This means correlation.
There is correlation, but it's minus negative correlation.
So as a report, this is the average rainfall in top five countries, it is Colombia, only is Solomon Islands. As for the top five countries, of course, as the Barbados is Brazil, China, Vietnam, Nepal, Indonesia, and USA. For the average yield in top five countries is general, savings, and foreign rates. For what was fertilizing use in top five countries is Hawaii, Taiwan, and rates. Next is a graph where here is the about and back about 2016. Yeah, it's quite accurate. I just have this from 2005 to 2017, and the confidence very widely. Here, the area is 50,000 per hectare per hectare. So the average rainfall, most of the data is above the median, which is the median is 1,000 millimeters. This is not a bad graph.
Bar plot? Oh, Bospot, ya, Bospot.
Salah tulis the amount of recycled plots is very likely, so the issue 100,000 tons. So the amount of fertilizers, then see the standard and get it without what is. So we chose this of the machine learning we chose.
Just it's explaining the
So this is the result that I'm discussing. We have the R-squared. R-squared is the mean absolute error, mean squared error, root mean square error, max error, and mean absolute percentage error. And this is the training time and the precision.
What's the discussion? From previous table? Previous table? So 1, 2, 3.
This is the accuracy.
Okay, so from all
The most-
algorithm, which one is first?
From the table, the most accurate is random forest and
So for the final analysis is that for predicting farm yield for precision agriculture, the best algorithm is the random forest, the highest of R2 value of 0.9 and has lower error rates compared to SGBoost and TNN. This indicates superior accuracy, precision, and minimized error, making random forest the perfect choice. Even though SGBoost and TNN have the same R2 value, but their errors are also higher, so making random forest is better to use than SGBoost and TNN. So the SGBoost model, while sharing the same R2 value, has a bit slightly higher errors in reinforcing the superiority of random forest, while TNN showed the competitive result, but with slightly higher errors, so random forest is better. So this is our result of using random forest. And comparing to other machine learning, its error is lower and so this is the comparison between the two other machine learning like XGBoost and TNN. They don't have the same R2, but their error is like
we see this in the table, right?
yes. So this is the conclusion where after yes,
So what is the insight? what do you find with the rainfall, or the pesticide?
So we find the top 5 countries with that's found
You don't need machine learning, you just need to sort the data and then you can find the highest country with the one reduced, right? How those features affect the yield? Is it the better, the higher the rainfall, the lower the yield?
This the example in statistic is you can use it. It's very similar. About fertilizer numbers, the plant, for example, is, and then, yeah, it's an watering fertilizer, chemical fertilizer, with fertilizer. So,
Yeah, that's the topic. Finally, you can turn it into something that you can sell. Yeah, you have the selling point. You discuss about how corn grow. Yeah, the one that I don't see is the inside. You have to give me the inside of the this. I don't know that is the best. The worst one is good. Bad. Can you show me the book? How many years do you have?
10 years. To 2019.
10 years. Do you see any trend from the last 15 years? For example, is it increasing the yield or anything that you can see? Or is every country has the same yield?
We didn't really see that part. We only noticed that, like, when testing different models, each of them have different feature importance.
Of course.
Yes.
So even when you run it again, they will change the number of the importance.
But I saw that majority of them, the feature importance is like rain and pesticides. Fertilizer doesn't really have a lot of effect.
Then we need to dig into those two features. See the trend over the years, how it affects the yield, how it is different from one country to other country.
so which the statistic that hypothesis is easy actually. So many hypotheses that you can create, right? Okay. So what kind of hypothesis do you think? It's exactly in the example.
Hypothesis like rain would most likely heavily influence.
Okay, no hypothesis for that one. No correlation. Right. Okay, little thing, including document. Right.
Reduce the amount.
Yes, you don't explain anything in statistic now. You put box for, but yeah. Okay, let's explain the data, but the hypothesis thinking and the requirement I see it. So many things that you can do with this data.
This is very nice, yeah. Data is complete.
You can compare Asia with Africa, you can compare so many things. Because corn actually is not for hot country, warm country. Yeah, based on that, you can compare.
Can grow in most climates, but mostly warm.
Yeah, about the hot.
Yeah.
Do you have the temperatures? No.
Oh, wait.
Because we use like all countries, it's hard for us to find like a website that has all the countries' temperature. We yeah, I mean, if you want to include countries, you have to like search it one by one by the countries. Date month of no this year.
I want to see more insight. Yeah, we can do a lot of things, but I know that we don't have enough time. We just do it like yesterday, right? But yeah, you can still have like 1 week for the report, and I don't know what the best statistic.
Yeah, one can do statistic, one can do more project globally. So we do a lot of research actually on this.
Miss, sir, can we just maybe get data from 2 countries and just compare them? Or is this fine, but we just need more insight?
More data.
With this data is enough, but you need to put more explanation here, more hypothesis. Okay, that's all. Okay.
Thank you, Miss. Thank you, sir. Thank you, sir.
More explanation.
Mana ini? Ini. Ini mana nih? Balik gak? Enggak, itu sama. Oh. Oh ini.
Oh, yeah.
Good morning, Ms. Ilana. Me, Arby, and Jeffrey will be presenting our final project for low data science and also statistics. So our topic is the implementation of cross-selling and cross-selling models in customer relationship management for revenue maximization and budget. So for background, kind of like why we did the project itself, is because the current revenue maximization strategy is still inefficient and we would like to make it more efficient. And our three main methods are to offer practical insights to improve the upselling and also cross-selling strategies in the company's CRM framework. And the next one is also to maximize the revenue of the telecommunications industry through the upselling efforts, and to also utilize supervised machine learning techniques to develop predictive models and a reliable recommendation system. Okay, so these are the data sets from the company that will be used in their code. The first one is a customer ID, country code, and and then this is the workflow that we went through for reprocessing the data. So first, they must do data, the first one before our presentation and then after. So we concatenate both of those for the new subscriptions data. And then we handle the missing values using the annex function, which is the formula. And then we did data type conversion to that formula right there. And then we also did standardization to all lowercase. We also did replacing invalid responses that did not match the criteria to not valid. And then currency conversion to
So basically how we label our data is we divide it into two labels. The first, we build two predictive models using two labels. Here is the first one, upsell event opportunity, where a user has successfully subscribed to a higher service price. And the second one is the cross-sell event, where a user has subscribed to a different service than the before one, and or he changed to a lower service. And this all can indicate like the possibility a user might have a success in like presenting like upsell or cross-sell event. So these are the machine learning algorithms that we use. First one is decision tree, and then XGBoost is where boost random price with trees and
Okay.
okay.
Okay, so for our hypothesis, what we do, the first one is discussing about that the cross-sell answer. The cross-sell answer is independent on that data, and this is for the hypothesis one. And the second one is the alternative hypothesis, and it is the opposite, so it was no significant factor. So this is the second one, and basically the second hypothesis is discussing about that there is no significant difference between the mean revenues and multiple data sets. And the alternative is just the opposite, which says that they have a significant difference between the mean and multiple data sets. So this is the description of numeric features. We got this using the function that described. So the one is the cross-sell and the third one is the upsell.
Okay, so for the development condition, we had two conditions. One for the upsell one and one for the cross-sell one. The upsell one is where the condition was that the customer would be likely to pay for a service which is higher than the one that we're paying for right now. And for the cross-sell, it's for when a customer is likely to buy different service but at a lower price. So these are the data that's that description. Okay, so next is the customer distribution by country. This is based on customer ability. This one is for the upsell, and this one is for the cross-sell, and this one is for the overall.
Okay, so these are the customer distribution by operator, sorry, overall data, which has the same result as cross-sell and upsell like data opportunity, where AIS stands the most operator that impacts the most on the revenue. These are the AHMED given opportunity for the upsell and cross-sell. We found that missing values, a lot of missing values in AHMED by the company were not found. It's has a lot of distribution here. For source, you can see that SMS turns out as the most distribution, or has the most customer, and also an absolute success. And then subscription cycle, it's daily subscription. And we also see the service distribution by each event opportunity, where the overall one, it shows for the upsell one, we can see that it's different from the cross-sell success event opportunity. And for the currency, that stands out as the most people subscribe to service using that for ILA. Okay, for distribution of subscription duration, you can see that here it shows that less than 7 months or 8 months, or around a year and more than 2 years subscription duration has the impact to a customer subscribe to a higher service or an upsell success. And cross-sell actually they has distribution here where it shows the less than
half a year, we'll have a higher chance of cross-sell success.
6 duration.
Subscription duration. It's like
Duration.
how long they subscribe to, and we can offer like upsell offers.
In days.
In days, yeah. These are the revenue trend over time. This one is for the subset and this one for the premium and rate. You can see that the latest data shows that a lot of people actually accept like upsell effort or upsell like service from the company. As you can see the data.
So this is the description of subscription rate feature for cross-sell and basically cross-sell and upsell they have the same results. So the first one is for a year, both of them is the highest subscription rate and then one for August. For subscription rate for the subscription rate, cross-sell is highest in this rate, the 17, and then for our it's 7. This is for the upsell, and as you can see, this is the premium and rate. So this one is the highest. August is the highest again, and for dates, it's also like in this one, so this one's the highest. And for premium, however, we don't have the data for analysis like
What is different rating?
Doesn't Okay.
If you want to highlight the highest, it's the highest.
Okay.
So this one is for the cross-sell for the premium and rate, and it's pretty much the same. But this one, for the highest, or the highest month is August again, and then the highest also in the month, and then premium August. Okay, so for the statistics part, the first thing that we did is we did one that's for the data, and the other was for now. And this is the result. So for the cross-sell and upsell, both of them has a smaller p-value than 0.05. So the alternative hypothesis is accepted, which is the cross-sell strategies and also the upsell strategies have significant impact on their behavior. And then the second thing that we did is we implement independent tests or tests. So this is the fourth one. And this is the result. So it is smaller than 0.05. So the alternative hypothesis of so it means that there's significant difference between the mean and the two data sets. Before that, we also wanted to do a Pearson correlation. But because our data already have non-numerical values, so we cannot.
So for the model performance of our algorithms, the algorithms, for the upsell model, the XGBoost came out of top, as you can see. It performed the best out of the other 5 algorithms, and the log loss score was the smallest. And same goes for the cross-sell model, the XGBoost and along with the primary performed the best, and their log loss score was also the smallest. The first one is the XGBoost, so this is the feature improvements. As you can see, the most important one, the highest, is the converted service price, followed by subscription duration and period and month, and then the others. And next, for the feature improvements in the revenue for us, the most important one is the subscription duration, along with the period and month, and first month, and so on. So these are our final recommendations for the content industry. So we recommend to concentrate cross-sell and upsell efforts in Congress, because from the people that you see and our case wise, it was the highest earning months of the entire year. And so they
on that month, it is the question generating revenue. And next thing is to prioritize analyzing the factors of deviation and also user engagement to effectively do the concept of Excel events. And lastly, it would be best to schedule the customer Excel meetings in the afternoon around 3 p.m. because it is the highest scheduled subscription acceptance. Okay, thank you for listening to our presentation.
Wait. Which part of machine learning? Okay, upsell.
Something when you create the label, how you create the label and what.
Okay. So.
Just to be one upsell.
So.
Features and
Okay. So basically, for upsell model, we started to convert first, actually, for the revenue and service price, and then this is when we created our label, where we define like the label is true when a user has subscribed to a higher service price than before, and we also fill the first a few data before, because we don't know that they have subscribed to a higher service or not. So we fill the first a few data false first, and then
that month or for the whole duration.
For the whole duration first.
For the whole duration, so you find the customer that's going up.
Yes. Yes. We group by ID here.
ID is the customer.
Yeah. We define that as our customer, and we also see that ID or ISDN, it's the same result. So we decided to use ID, and these are the process where we encode our data, and we actually split all the columns into time features, and then here. Oh, okay. So these are the subscription duration where we checked first the condition where the unsub state is null or not. If null, unsub state will be reduced to substate, or if not, the created at or the date when the data is retrieved will be reduced to the subscription date. And then these are our features and our label. We start making functions to plot our confusion metrics and evaluation metrics, and also shop values. So these are for the XGP classifier. For the results.
Have you tried to put the ROC curve together from all the models?
Put the what?
The ROC curve.
Oh, ROC curve and binary confusion matrix. Put it together, or
ROC curve together with all the other models.
Oh, we haven't tried that, but we actually implement ROC curve for all the models.
Yeah, but you didn't do three in one.
Oh, okay, in one graph. Okay. So these are for the XGBoost and the feature importance and the shop values. And his gradient boost. So these are the RC curve and confusion matrix and shop values and. We actually tried to build the person collection matrix, but our features are too a lot, and the matrix is not that good to visualize, or we cannot see really a thing from there. So we try to use feature importance rather than the person collection matrix.
What beginning and month is the third?
Maybe it indicates like premium and month has like impact to customer who subscribes, where we can target those like and month after that yeah.
After they're done with their freemium and month, and then we would it would potentially be a good strategy to do upselling and cross-selling. So maybe that's why it's important.
So does it mean if the month is like end of the year, it always goes up to the higher level? The month, right? So
yeah, the month.
will go up.
It's like in a certain month that we showed before on our visualization or EDA. In August, actually showed the most like
The most upsell.
upsell event. And these are for the other algorithms such as decision tree, random forest, Gaussian naive Bayes, KN. Okay.
I just want to state the reason, like why this is coming as the best features, what is the logic behind that.
Okay.
Should we put that on the paper or?
Okay. We explained that on the paper.
Yeah, just highlight the importance of the findings. Okay. You can put it in bullet points so we can see.
Thank you.
Okay.
Thank you, ma'am. Okay, thank you.
Thank you, miss.
Have you filled out the peer review?
Yes.
Yes.
Oh, the next. Just prepare your slide. Abbas went to the restroom.
No?
Oh
yeah, she itu operations. Zoom-nya di sini. Oh, we joined the Zoom. Oh.
You don't have the back bullet. Yeah.
Meeting ID. Why mati. Udah.
Yeah.
Tapi aku bisa lebih ke.
Okay, you because I.
Aku masuk lagi. Waktu itu bilangnya mau ya kalau itu bisa masalah.
Saya jalan apa itu sih?
Kok kan itu? Ini gimana? Ini. Lah, kok gini? Oh. Apa sih?
Bukan
Good morning, Mr. Bahman and Ms. Nurul. Today our topic is programming global models to improve the SRE efficiency. So for the main objective, we discovered what is creating the obstacles and finding features that are positively impact the telecom operator company by limited safety and expressing the data from the given data sets and data models to clearly show trends and eventually what is making cycles and outside of effects and organized for the hypothesis, we're actually implementing the statistical statement, but turns out our data is but turns out our data is categorical and all the numbers data are not complete, so we can implement the class but we've tried it before. So here are the data set for the clustering model. These are the columns and the information, the little bit description of the columns. We have operator, total service, service source, country, publisher, and these are the description. And these are the data set we choose for the classifier. We have the operator, successful link, service request, substate, time charging, renewal date, revenue, substate, transform, purpose, service, country, publisher, and they have. That doesn't follow your policy. Use different data sets.
Oh no, this is basically you're wrong for the classifier, basically. Yeah, we haven't changed it yet.
So here is the relationship between telecom operators and the countries in which they live. And there are, so this is the gray node represents the countries and the red node represents the operators. So there are a total of 6 countries that were present in our dataset. So Thailand, Laos, Indonesia, Oman, and Philippines. So this is the relationship between operators and services. So in the context of our problem, operators are the users and the services are the services that they purchase from the company. So the green node is representing the operators and the red node is representing the services that are made for these operators.
Why there is 2 operators that connected to each other? On the right.
This one?
Right.
Most right.
Most right. The most right. This one? Yeah.
Right. Alright.
Yeah, this one. Why is this the operators?
Because they share the same service.
It's supposed to be like this, right? Why they have the operator has the operator.
So that one operator different operator.
Like this, right? One operator has the reciprocal service. This one should go to this one. And this one.
The issue was the question. We tried different words and
so this is wrong.
For that one. So to help the advertisers target the right users with the right ads with the right channel, we decided to implement both supervised and unsupervised learning models. The supervised learning models that we implemented is the cluster model, and the other one is the classification models. So we implemented K-model cluster algorithm so that instead of focusing on Google, we focus on Google because we focus on classifying data based on data attributes.
Okay. So for our results for our testers, these basically just made it into Google. And as you can see here, the optimal p-value determined the number of clusters is 10, so that's just the total of the different necessary clusters. And we decided this based on using the values of active operators, which is basically the operators mentioned before in the library. But
the 6 countries can be basically classified into geographic-based groups of customers, depending on like their respective businesses, like their services and services. Now, moving on to the entropy, which is basically the level of disorder environments within a data set. In this context, we concluded that it's 2.81, which is relatively low in this case, which means that the algorithm has produced clusters with higher internal mobility, where data points within each cluster exhibit similar characteristics. So these are example cluster individuals of each cluster. So this is Senegal, Indonesia, and Thailand. So as you can see here, each row has their own category, like the ones mentioned in the table. So this is the operators, like the Senegal is Senegal, orange and active, and then Indonesia is Hotel, and Thailand is AIS. And then this is very self-explanatory. The customer for Senegal indicates that when sending ads related to the business service to users of this orange and target operator, it's most effective to use the SMS channel. Same is true with Thailand, but obviously it's a different country and it's different. For any inquiries and information regarding the service, contacting AIS through this channel is most effective. And then for Indonesia, which is most common through Telkomsel. Hotplay service is associated with here. To reach users of the service, it's recommended to use the web source, and the afterward is so for our classification algorithms, we use 5 in this project. We have XGBoost, random forest classifier, decision tree. Basically, XGBoost and random forest classifier is basically an extension of the decision tree, where they use decision trees to make predictions and suggestions and assumptions. And then next, we also use logistic regression and human narrative.
So these are the evaluation methods that we have used in order to measure the performance of the algorithms. So this is the target variable for the classification models. So there was no category in the data set that was a target variable. That could be used as a target variable. So we decided to use proxy target variable to be successful. So it has 2 values. 1 represents successful interaction between users and the ads, and 0 represents unsuccessful interaction. So this feature importance for the classification models. It just shows the importance of the features in the training data. So this is the correlation of the correlation between each value and the success rate. So the thing is, so the success rate is not a continuous variable. So the thing that we do here is, for example, the positive correlations between value and the success rate is, as the positive value increases, the likelihood that the success rate is 1 increases, and as the value decreases, the likelihood that the success rate is 0, which means unsuccessful interaction increases. Because the success rate is not continuous variable, and that's the reason.
Yeah, also the source and ground. You input the country into the right?
Yeah, but it's not continuous. So this is just the number of interactions per surface, and this when the success rate is 1. So MS and the goal, these are the number of interactions or the frequency of this surface when the success rate is 1. So this surface is the top surface by revenue when the success rate is 1.
What is the other one? And this is by revenue, the other one?
The other one is just surface with the success rate.
The number of interactions?
Yeah, frequency.
Or how many times they...
Yeah. So for example, how many times the effort of the surface received interactions. So the surface by revenue when successful is one, meaning if it's a successful interaction between the user and the iris surface, how the vector is affected in that place.
It's interesting and slightly from the other graph, slightly, is it slightly or slightly? Okay, can you check the previous graph?
Slightly.
Oh,
yes.
So Goli has more interaction, but generates a lower revenue, right?
Yeah.
It depends on the surface price.
Yeah. It's not.
So like this graph, this just the top surfaces. There are a lot of surfaces, but if the top, some of the top surfaces are exposed, then we decided to just use the top surface.
Okay, so yeah, this is what we included from each algorithm and their respective evaluation methods. The ones bolded are basically the highest in their own category. Our final analysis is basically with 90% accuracy, precision of 80%, and an F1 score of 31. Actually, most algorithm demonstrates a good overall performance, even though its recall score is relatively low in contrast to the other algorithms. It still outperforms the rest. In the context of ads targeting efficiency, focus on precision is really important as it ensures that resources are allocated efficiently to users who are genuinely likely to engage with these resources. Precision of 0.8 indicates that when the model predicts the user will engage successfully, it is correct about 80% of the time. This shows overall good performance, but also shows there's room for improvement as well. And as for the worst performing, Seniors and inverse performance are worse because in terms of accuracy, precision, and score, the scores are all the lowest among the candidates. And due to the low results, and that does not align with our main objective and hypothesis in earlier, this algorithm is not recommended for this case.
So,
yeah.
Just want to add something for the nature of our data set. So our data, the features that we selected are mostly categorical. And at the same time, there are some numerical features like the success rate, but they are not continuous. So we try to implement the C-test or the T-test, but since it is categorical and it's not continuous, calculating the mean and the standard deviation was not possible. Although we include it, it's not continuous data, it's just a values. So and then we just decided to make this statement for our hypothesis and then analyze it for our
Can you just the range?
Oh, range.
Range. So, yeah, just the yearly or monthly, compare with the previous compare with countries, many things.
Oh, there's a country, compare with the countries.
So,
the data you give a range of the data.
Possible range, yeah. Range.
Yeah, between the success billing from last year and this year, for example, between months. Comparing the same financial. Can you show me the code?
we have to call the code, right?
Actually, it's interesting, yeah, to see the top 5 sentences and then you start analyzing why this is not generating revenue.
Yeah.
And then maybe go into specific areas in the country.
Why it's not making revenue as much as the other.
Yeah. You want to sell money in the other country.
Yeah, Abbas, like I have meeting ID. Abbas, meeting ID, the meeting. You have Zoom?
Analysis, like business analysis.
Okay.
You have Zoom?
You have to go to Zoom.
Yeah. Oh, you already put it on the forget.
It's not that.
Oh, you just want to show the code. Kayak monthly atau orange? Iya, range. monthly atau bisa sampai minggu ini kayaknya.
That's why we actually struggle to make something. But it's very interesting.
It's a visualization. You can change the layout, right? Spring layout, they have several layout, right? Simple layout, and more text. Yeah, try to implement it. So they can report ID, yeah.
This is
The X. Everything is the This is the comments I put it in the section, yeah.
Stop share. Next, itu udah di depan ya? Abbas, this one?
I could have sold that. I could have sold
Participant dan
Why like this here? Oh, this way.
I don't know, Joy kayak nggak bangun, Miss.
Soal paling bagus punya siapa? Soal paling bagus punya siapa sih?
Nggak ada yang bagus.
Ya, kalau saya jelek, saya bisa tanya gitu sana. Bagus.
yang bagus itu yang nggak rush, yang ya.
Sering revision gitu ya.
Ya, bikinnya mana? Saya juga apa? Sabar bentar ya. So,
what are you doing?
No additional time.
How many minutes?
Until 11:38.
Our project not long, so. Right, so good morning, Ms. Nurul and Sir Monica, and Today we're going to present our final project, which is about our prediction model of mental health from social media usage. So the members are Carlo, Joanne, and me. So, as a little introduction, in today's era, the widespread growth of technology and the internet have rendered social media a very fundamental aspect of everyday life. Platforms like Instagram, YouTube, Snapchat, and many others are not just digital spaces for interaction, they have become a necessity for connection in the modern world. While these platforms offer numerous positive aspects, including global connectivity, they also harbor many potential negative impacts, especially on
What's your name? Okay, what the
fine, skip. Basically, our aim is to check, so let's just give us a minute. So, we obtain the data from randomly. So, basically, the data set consists of media use pattern, which is the length of social media usage, and then their mental well-being scale, utilizes the Warwick and Lundberg mental well-being scale, and mental anxiety scale, and of course, demographic data such as age, gender, and habitat. And so we basically compare machine learning models and which one can predict can connect media use and so we basically make a new depression column from mental well-being and mental anxiety. Can we just run the code kalau gitu biar gampang?
Yeah, run the code.
How many slides in your notes show?
20. Oh.
They just copy all the report.
Yes, yes.
So, yeah, good. Your hypothesis?
There's hypothesis. So we just basically we hypothesize that the feature importance that will matter the most is the age of the demographic and also the media usage. That's the null hypothesis. And
So, what the null hypothesis?
Age and their media usage per day.
It's affect
the depression in the prediction model.
Usually there is no connection.
Oh,
Okay. Now, what is Lars Peters over there?
That's the template of this presentation.
Okay, continue.
And what it is.
You should already know. Continue. We'll see.
Just run the code.
No, the phone.
The font?
Yeah,
So first, of course, we will load the dataset, and so in the dataset, the features categorical features and numerical features. So the first thing we did is we modify the categorical features into numerical features. So as you can see, for education, we just changed to integers 0, 1, 2, and also for other columns. So next, just run it, Carlo. So here's the correlation heat map for our data set. So yeah, as you can see, for media use, very big 0.1 on every unit. So yeah. And here's a box plot for the well-being scores. So the reason why we use a box plot for distributing the well-being score is to determine depression levels. So since we're using classification, we need to have depression and non-depression. So to determine if someone is depressed or not, we take the people that is well-being score less than the median, and let's.
Is this supported by some research? The reference?
Yes. So and the anxiety score is going to be above the median. So if you look at the result using this for the balance. As you can see, 26.3% is depressed and 73.7% is non-depressed. This is about the if you search using references in if you just search the amount of adults that is diagnosed with depression is also about the same. So it is supported by it's not asal. Okay, so here's our confusion matrix for logistic regression. As you can see, ini yang result barunya atau apa? Ini result baru.
The new result.
New result. So as you can see, this is for logistic regression. This is the confusion matrix. That is the result. Position 0.7, recall 0.7, F1 score 0.7. Yeah, and accuracy 0.7. So as you can see, for the feature importance, again, age and media use is the most prominent.
Next time.
Next time, for the unit searchings.
We have like the table that shows all the results.
In the report, yes.
In your PPT, no? That's right.
No.
No?
In the PPT, only in the code.
Just the
And in the
conclusion.
report,
What is the highest?
0.86 with
Canon, but the feature importance,
so this is for random forest, pretty high. And feature importance, also again, sesuai hypothesis, age-nya tinggi, media use tinggi.
What the finding that you found from the reference regarding your work?
Well, that media use is basically it's mostly about media use being very well and application and stuff. So
And is this proven yet?
Yeah, it's proven.
In our results.
How about the age?
Well, for age, well, since most people that use social media, according to research, are adults, and usually the older you get, the depression also.
Nice.
That's in.
And non-breathing is in your report. You creating a table?
Yeah. But yeah, takes a long time to help. Tapi accuracy is fine, and sesuai analysis kita di awal, which is media use. Even though media use isn't the most prominent feature, it definitely.
What is the most surprising finding from you?
For me, the fact that how little habitat qualifications gender
How small?
how small comparing to age and media use. For me, it's that. That's the most.
Is there any reference that say that the gender and habitat
Um,
lead to depression?
There is, but in our data set, most of these yang masuk our data set, qualification itu, they're all kayak apa? Ya maksudnya udah tinggi pendidikannya. Jadi mostly they live in rural areas. Ini cuma kayak di kota atau di Well, that's for future works. Maybe bisa di-increase qualification-nya apa mungkin
So it's not in the data yet?
No, it is in the data, tapi data kita yang kita dapat lama aja nih. So I think easier to explain, sir. Easier to explain. Thanks for giving this report.
So that is boosting. For the nearest neighbor, the
best. Yep.
So what's social media? Is data? Is data again from which social media?
Manually, no. The data we use a combination of all social media counted by researchers from the local theoretical social media use.
Did they publish their work?
They did in. I think so. Yeah, it's in.
It's in Mandu.
And their findings?
Their finding is actually there's negative. There is no correlation because they didn't use machine learning. They only use surveys. They only use surveys.
So this methodology is
Based on machine learning. So first, their data set is the researchers. They counted their mental well-being score, their anxiety score, their media use, and then they give out surveys to each of them. And according to their survey, there's negative, but according to our machine learning thing, there is correlation.
Statistic? The result? So do you have your hypothesis?
Or the results of the hypothesis?
So your hypothesis is, okay, the null hypothesis is, you said correlation, alternative no correlation.
So if that's wrong, that means.
No, yes, yeah, sure. So the result is?
Well, the result is there is correlation because in the data set, as I already showed the feature importance.
So actually you reject the null hypothesis.
Okay.
Yeah. So let's again about the null hypothesis. So yeah, even the exam you will mix up and then wrong and the what else?
Good. Our hypothesis kebetulan nice. Right, sir. It's just vice versa.
I really don't know the basic there.
No, not the basics, sir.
So Joanna is not going.
Have you filled out the peer review form?
No.
Not yet.
Not yet?
Yes.
Otherwise you're gonna get a score.
Okay. Okay, hypothesisnya aja.
Okay.
So you have 1 week to finish the report, but the paper due today.
Can we give the paper to me?
Submit just the paper to the link. If you already have the report, you can submit it together on stage 4. Yeah, if you
Okay.
just finish the report, the paper, you just submit to stage 3.
Thank you.
Report.
Yeah. Okay, thank you guys. See you.
Thank you, Miss. Thank you, sir. Sorry, this
In front of your score.
Tapi nggak apa-apa hypothesis kita.
Actually, the idea is unique. I like it, yeah. And then it's not really happening.
Oh, yeah, I thought it's good.
Because I gave different information. That's very good.
Sorry, sir.
Up
Itu yang kemarin kita
Kayaknya harus di share screen kayak itu deh.
Iya.
Soalnya ada live YouTube deh.
Tinggal langsung ke sini. Hello everyone. Hello Miss and Sir. Today I will present you. Tunggu menit ya.
Iya.
Kayaknya enggak deh. Kayaknya 20 menit juga.
Kita kan
Ntar ADA kapan bu?
Iya tahu. Ada di grup. Yang pertama kita apa sih? Senin database.
Lagi gimana? Ini nggak sih?
Ini betul. Ada yang kok nggak bisa?
Sampai.
Yang lain udah
Udah. Sini. Berarti yang modal teknik sih enggak kan? Atau iya?
Model teknis aja dong.
Oh iya.
Cuman kan Aing nggak jelasin di dalamnya, cuma jelasin implementation doang.
Benar gambarnya?
Apa?
Oh iya. Oh enggak nih. Maksat. Hai Miss. Masih Miss?
Masih.
Okay, hello, Isro and Sir Mahana. Today we will present our current project, which is the implementation of machine learning to maximize charging concept of implementation units.
So starting from the problem statement, we have 3 problems currently. So with the advancement of technology, every company has a chance to lead the marketplace and win the users there. But one thing that the company needs to have is the ability to manage many customers while providing the best solution. So therefore, we came up with 3 problems. The first one is they need to win the user's heart. And the second problem is with more than 160 million subscribers, it is challenging to manage that amount of subscribers. And the third problem is the charging efficiency is an recurring problem with today's society, and we make conflict with our solution, which is to provide a data model and identify the problems with the data sets provided by the IT. So for our methodology, in order to provide Link IP 360 with the data models to improve the charging efficiency, we're going to use the subscription dataset right here. The reason we use this dataset, other than using the other datasets given, is because there are many features that correlate with the problems that the company experiences. One of the way for the datasets to be useful for us in order to make a reliable data model is to clean the data, which is a procedure for preparing or eliminating inaccurate, corrupted, or improperly formatted duplicate lacking data from the dataset. With these are the columns, and the description is summarized. So for the statistics, there is a null hypothesis and alternative hypothesis, which is null hypothesis is there is no significant association between the source and successful target attempts. And for the alternative hypothesis, there is a significant association between the source and successful target attempts. And for the dataset pre-processing, we first integrate the old dataset with the new dataset provided by the Rumos Hive. After further investigation with the process of cleaning the data, we found out that 3 columns out of the chosen columns which have the missing values. Missing data can be imputed to avoid a reduction in precision and a higher probability of bias conversion coefficient. Therefore, the process of imputing involves adding actual values to the datasets and result. The next stage of our pre-processing is assembling the data to convert all date or time-related columns by changing their format. And this is a dataset report analysis and visualization. So after cleaning the data progressively and handling the missing values in certain columns, we'll provide visualization of certain data that relate to improve by charging efficiency, IP efficiency, and we will provide the graph later between the relationship between source and success billing, pie chart of Asian and non-Asian countries, total of success billing by Asian countries, optimal time to charge during subscription, optimal time to charge during renewal subscriptions, and total of customers based on their stats. So these are the graphs that I mentioned.
Explain that.
So the total success billing by country, the total success billing row is there, and the country is here. And LA having 80 the most, 812,196. And the distribution of Asian and non-Asian country, with this color being not Asian, and this is the Asian, 77.1% and 22.9%. And this is the total success billing by subscription type category, which is most in the morning. And the total success billing by subscription type category, which is for non-Asian country, same as well in the morning. And total success billing by renewal time category, same, the most in the morning for Asian.
And one region, same, also. And for the model techniques we use, there are features and labels or targets. First one is subscription history, which is explaining about the history of subscription made by the customers, and then there's customer activity, which is about customers' activity, whether it's recent or in the past, in order to prevent false charge attempts. These features include cycle and worldwide information, which provides us about the user's location and network in order to know which part of the region of the company that needs to improve. These features include country and source, and for the label, success billing is to investigate how many successful charge attempts will occur from the machine learning. And these are the predictive models we use. We have decision tree, random forest, XGBoost classifier, this median boost, 10 years later, and logistic regression.
And in order to predict our algorithms for our machine learning, we use 5 machine learning, which is the score, advanced score, call, precision, and ROT. And these are the results for our machine learning, and from the table above, we see that the XGBoost classifier has the highest accuracy compared to all of the other machine learning. And also the second one will be the this gradient. And for the machine learning that's performing the worst will be the logistic regression. And in terms of factors that determine in order to improve trading efficiency, we found that the features were the amount, and X. These are the feature importance for each of the machine learning, and from as you can see this, the vision and the vision learning bars has the same feature importance. Like the top here is very well month and the status, and these factors as the denominator for the efficiency and the substrate for the year, especially the year on how the company should do it. And these are the feature importance for the history and boosting and also XGBoost. It's the same with month on the top, followed by the year and status. And also like the worst factors, these features as the substrate and also substrates for both. And as you see, the affect the charger efficiency, and for this in the substation month, July is the highest. July is the month that has the highest cost of billing, over 300,000, and for the renewal billing, also by the month it is in September, which is over 500,000 success billing.
Why did you say the highest in July? Why?
I think it's because of the
You can put it in the report, the analysis. You just don't just show the image, the visualization with the analysis. I want the analysis further. Can you see the pattern and why? You find out from the reference, from how to do the data, from the supporting model.
And these are the correlation methods for XGBoost and also the ROC graph for the XGBoost. And from the ROC, we see that the score of the XGBoost is 0.6, which is quite high for this machine learning. And these are correlation methods for XGBoost. So source and the status being the largest importance, largest percentage of affecting the success challenges. Policy for growth efficiency and identifiers. With efficiency, the score is 0.4 and the identifiers is 0.16. And these are the policy for the logistic and K-mears neighbor with both of the score are 0.96. And these are for our statistic. We first divide the source and sensitivity into two columns, and then we calculate the p-values. And with the after calculating the p-values, we found that the p-values is equal to 1, and the ratio of both success rate and the source are 0.6. If the p-values equals to 1, it is greater than 0.05, which is our actual values, which means that it supports the null hypothesis that the source doesn't have significant effects of success rate. And for the data science, we conclude that the XGBoost perform very well in our data sets in order to predict our successfully based on our features. And we suggest that the use of XGBoost in our data and the use of logistic regression is not recommended. And for the features, as I said again, it is the month and the time of how we publish, when we publish the treasure. Thank you, Chris. That's our presentation.
So, you test the hypothesis specifically, sir?
With Fisher acceptance.
Version 1 or 2?
Sorry.
1 or at least two formula?
Yeah.
Which one?
Oh, the one. Because then there's two columns there, and therefore the formula for the Fisher acceptance have two columns, which might be there for one.
Can I see your code?
Okay.
Gimana caranya disuruh bisa. Mana?
Okay, one finding out how to make it bigger.
So this is how we basically when we data we separate the file. It's how we compute the text and also the machine. Well,
So what you're trying to predict?
we want to very successfully based on features, which is like the line.
Did you include the attempt jumping as your feature?
No.
Oh, what did you include?
We input the status by the source to the company, then the subline, remote date, remote time, and the category of correct mining, and
Can you show me the X? Or you define X? The X. X and Y.
Font size-nya X and Y.
how we define the X and Y in here. So just as a algorithm yang tadi bilang, and another success algorithm. And this is how computer dictionary. Nanti kita buat eksperimen tes, macam tes kita pertama create dulu the YFX, and then after we train we test with our machine learning.
Oh, you try to predict success.
Yeah, we try to predict success.
Success belief is 0-1.
Ya, jadi how we define field engineering itu, kalau saya sukses di zero, it is considered as field engineering. Kalau misalnya itu one or above, itu udah sukses.
So primary.
Primary.
Yeah, because judging from the result, it looks like you have identical value from the feature and the label.
Yeah, so yeah, for our features and label, for all features, it's always the same.
What do you mean?
So yeah, features and label, but all features are the same.
So what is the highest in your feature importance?
The month, followed by the category and then the.
What if you remove the month? Kalau
if we remove the month, obviously it's the status and the source.
No, I mean there is something wrong with your code.
Yeah.
I don't know which part, but it seems all the machine learning read the same value, which is uncommon. It's like above 90 something. It looks like you have identical value in your table, in your target, and in your features. It's like it's obviously seen without the machine learning. You know what I mean? Yeah. How to fix this is by taking out one by one features, which one is really identical. And then, yeah.
Ada the same value.
Yeah. There is always one for which month, I don't know. There is always one for which year, I don't know. It's like identical value. Like whenever the feature set is one, the target is always one. There is like pattern like that in your data.
But itu masih gitu.
You cannot say like, oh, this person is always buying the same thing every month. I mean, you don't have to run a machine learning model if you can see it clearly with your eyes. You just visualize the data, right? Machine learning is to help the user to figure out what is unseen from the data. If it's very clear, you don't really need to include it in the machine learning. Like for example, you can see visually that people tend to subscribe on July, right? So if you run only the month, and the success rate is always one. Yeah, it's always, you can see clearly, oh, July is always yes. Yeah, then July is always 0. It's always correct. And something like that is not really necessary. You don't really need to run the machine learning in order to find that fact, right? You want to find something else that you can find it without the bare eyes. Okay? Yeah, that's it. What makes your solution different than the other group?
Other group, I think they didn't use that much us, and also we want to monitor because you know.
It's not the reason.
And you know, parents.
You just change one method and then it becomes like another machine learning. You don't implement your own algorithm, right?
Yeah.
So what is different? You can just add another machine learning and it's become compatible. So what do you think your solution uniqueness?
That's how we implement the machine learning in order to build the strategies for the telecommunication industry. How we divide the data and then we solve the strategies such as how we can plan our strategy like the category of when we publish this successfully based on features
when you can see from the visualization, it's obvious July, right? Or middle of the month, yeah. And morning we can also see in the graph.
Also, from our machine learning time, we also saw the efficient improvements. Jadi, we know about variables that affects the successful.
Yeah, the group of the okay. Percent. Okay. Thank you.
Thank you.
Kalian mau bikin paper nggak?
Ya.
Nah itu, problemnya adalah bikin to have more selling point.
Simon Nicholas, Omino,
If you cannot even compete with your friend, you cannot compete with the other society. So, something that, yeah, people don't think about. Ah. Before I decided.
Enggak, ini sama si Abdul Muis.
Masih kok? Masih?
Iya masih di database dia sendiri yang Muis. Dan jadi sama si bukan berubah kayak dia dan itu orangnya nggak dia tuh jadi itu.
Iya udah bilang kayak nggak mau pindah jadwal itu.
Si Abdul Muis sama si Nicholas. Itu juga masih. Proposal tuh. Ini namanya lucu satu hapus di. Ini berarti satu hapus di kolom satu hapus di bahasa Latin. Bisa artinya Christian Church, Lamb of God. Come on,
You change your topic yet?
At first we wanted to change our topic, but then we realized that we didn't have the time, so.
So you
come on.
stay with the.
Yes, we stay football classes.
We'll just switch. Yeah. No, I'm not gonna. After one minute, we switch. After I talk to talk.
Yeah, right. So before next,
Okay, so Thank you for waiting for us. I will the last one to present. Hopefully, will be good. If not, then we are sorry. And as our proposing policies before you enter, accept policy agreement. So we are like, my name is Nico Santo. My name is Dr. Tari. And we have made a football goalkeeper analysis. So our problem was the fact that there are two types of goalkeepers, and one of them was pretty trendy back then. They're called traditional goalkeepers, and then the current day and age they use modern goalkeepers, which are similar in a way because they're two goalkeepers who still have to use their hands to play. However, what makes them different is the fact that traditional goalkeepers are usually not strong on them, but they're more comfortable with their hands, and modern goalkeepers are meant to be stronger with their legs so that they can also be in a good way and stuff.
This is our source for data sets. We use Apple and we collect the data from this website, from this and for both of our goalkeepers.
Just for confirmation, we also chose two different types of goalkeepers from the same era, but they have two different styles of goalkeeping. David De Gea is the pioneer for the traditional goalkeeper, and Mario Neuer the pioneer for the modern goalkeeping style.
But both of them are like from the same website.
Yeah. This is the raw data, and our main struggle was the fact that we have like a bunch of missing data, and the data from this is the data from one player, the data from the other player is incoherent with the data from this player.
Guys, I'm sorry guys. There's my wait, where's it's okay, just a bit of intermission for entertainment. I think I should. That was a part of the presentation.
So this data is from two players only.
This data is from one player. This is one of the data from one player we're showing you one, and the next one will be the process code.
Why the age?
The process.
What?
The age.
The age. Because in each season the player accumulates the age.
Oh,
it's the
So this is the year. This is the year data.
Yeah, this is the data for David De Gea. He's been playing for around 13 years. That's why he started playing since the age of 18 until the age of 21. Yeah.
But you decide which traditional, which not.
No, it was decided by the MPRF website that we use because there's a bunch of this position for people and we just chose the best one for each. CMP means completed and ATT means attempted. Like this is the completed amount of passes and this is the attempted amount of passes. And this is the completion rate of all the
passes. This is the process data.
We only put the latest ones.
This?
Because we want to see how they fare nowadays, the third. And that's why we only put data from the last 5 seasons, where it's still fresh.
I'm asking the volume.
Yes?
For these two, 340 ISA.
Oh, this could be one of our total distance.
Total distance from the place.
From the ground.
Yeah, the pass, the times of passes.
And PRG?
Progressive distance. So the difference between progressive distance and total distance is progressive distance is when you pass a ball from here over to the other ball, it counts as one. However, total distance means that it doesn't have to be going forward to the goal, but it also will go forward to the back.
Oh.
Like
the total distance like how many like ball the total one. Yeah, after like the whole like one way.
Distance of the ball that he kicked. Not the
No, this is from the.
So I can count also how many distance of how they run.
Yes.
Not this one.
We're trying to calculate the passes since that's what happens in the build-up. You score the goal and stuff. And that's what the styles are for. The traditional ones are not as passable, and the modern ones are always passing the ball. Show the long passes.
Do you have the description of each point?
Yeah, we do. We wrote it in the report, but we sadly didn't put it in the. And,
Next, you put zero lah. Don't put.
This is
no zeros.
This is a zero star, but
No,
it's
no.
Yeah, the Sanskrit one, but
we put replace.
I don't know how to put it in Canvas, so that's why.
What is no hypothesis?
Hypothesis like our HOA is to see whether the total distance that are covered by the passes are affected by the completed amount of passes alongside the amount of times. So yeah, in general it means that when the players are passing the ball due to the distance.
No, I mean it's not hypothesis, right?
Yeah.
So the no hypothesis, the result should be this. This one you still think whether so it can be this, can be that. So which one is null, which one alternative?
Oh, the result should be the total distance. I guess this explanation isn't really the best way.
Not fair, I think.
The result is the non-hypothesis is that the total distance is not affected by the number of passes and the amount of years.
That's called the correct one.
Yes.
This one is still better. Okay. This hypothesis is more than one.
No, only one.
Yeah.
This is the
visualization.
So we're trying to figure out whether this thing is affected by these two. But no, we already know whether it's affected or not. But the null hypothesis is the fact that these total distances are affected by the completed amount of passes or the attempted amount of passes. And the alternate hypothesis is the most.
So this data from media audio, not more.
This data is only from the area one. Yes. But we're trying to only show one so that we can get one in the report.
Yeah, but like we have both. We have both.
Yeah, that's it.
This is the position, the basics for the analysis model.
This is the evaluation techniques.
And this is the
This is the result.
We'll keep on for the model.
Okay, very good. How many data do you have?
Around 13 seasons, so around 10.
But you saw?
Yes.
Okay. What have you got to play there?
No, there's another.
No, you have
10 data? 10
row? Yeah, around 10 rows.
10 rows?
No, but that's only for one CSP. We did more than just one CSP.
We have three CSVs.
Yeah, 3 or 4 CSPs.
Yeah.
So how many?
100 or something.
Okay, why this is something?
Because because of the missing data, so we have to drop the NH and stuff. And then
the last data, how much?
At the end it only showed up for 20, and then because we're trying to predict the last 5 seasons or last 6 seasons, that's why it only goes up to 6.
So all the data that is not missing, how many?
Around 20.
20.
Yes.
Less than 30.
Yeah.
So even satisfied statistic number.
Yeah, I don't understand why the traditional you don't compensate for all because it's the data is there.
Yes, the data is there, but our idea was to compare the two goalkeepers. If we combine the goalkeepers, then it would be. I'm pretty sure because each goalkeeper have different styles.
Yeah, so it's traditional because you said the website that said this traditional, this modern.
Yes.
So you already You already separated.
Yes.
So it's easier for you to get like 10 goalkeeper traditional, 10 goalkeeper modern.
But each goalkeeper performs differently.
Yeah, that's why we need to predict.
What do you mean perform differently?
They play in different leagues.
I know. Yeah. It's okay.
We only compare the best ones. We chose the best ones. That's why we.
Yeah, the best one
for traditional goalkeeping currently. Yes. I mean back then. Casillas was around, but Casillas is not no longer relevant because he no longer plays. He was retired, and that's why his data only goes up to 2015. And the data that mostly goes from the below 2010s are missing. Based on the CSP statistics. Hugo Lloris only has the same thing as the hair. They only goes up to 26.
But that's one more time. Hugo Lloris still play, right?
Yeah, currently he's still playing. But the data
is traditional or conventional?
He's called a traditional goalkeeper, but his data is similar to David De Gea. That's why we just went with David.
No, I think don't use David De Gea. Don't use this. Why you use David De Gea in the beginning is also it's not clear. If you want to new warrior, the glory is not one World Cup. They can never.
No, but there was a big comparison between David De Gea and Manuel Neuer in these recent times.
So yeah, you have to leave. No, I mean, it's still one is not good for statistics. You can only compare it. Then what Europe? How about in Asia? Is it same? America is same?
I think it will be different. We only choose the icon, not iconic, but the more famous ones. So,
No.
Based on the website.
Yeah, but they are still to push the data of many of the problems. Why don't understand why you don't compare them to each other still?
Because each goalkeepers play differently and they're not really part of the comparison.
What do you mean play? They play. Okay, traditional modern, right? You agree?
Yeah, but some of the goalkeepers they in the list from the website, if you want to check, they also have goalkeepers from like Russian leagues and stuff. So
even this, your analysis is differently.
Yes, but they're still part of the big leagues that people watch.
No, I mean, as long as the column name is the same, feature name is the same, you can always merge.
Oh, okay.
Yeah, you can put maybe Europe only is okay.
So maybe.
Yeah, okay. If only you want to like again Bundesliga and Premier League, yeah, use all the goalkeeper for the
Bundesliga.
I mean, yeah, that's even though maybe the regional 40, modern 20, yeah. Maybe the sample is not good. So use population rather than this sample, right? It's better using population of.
So you say is like we should put like more goalkeepers in there.
Yeah, I mean, you set the range, the year first, from 2010 until 2020. Only two league, Bundesliga and Premier League.
So from that area, like from those years, like all the goalkeepers play, you should put them all. Oh.
This means population is better in the result. This sample is only one. Then if you want, after you get population, take from 2000, I don't know, one goalkeeper compare as a sample, or 2, 3 compare to the population. It's same the result. It's okay. It's interesting, but yeah, you not need more sample.
Yeah, unfortunately, this is very interesting topic, yeah. And unique, you've got the data, valid, yeah. The thing is that we have more data and different analysis.
We still have time to fix this.
For report, you have 1 week.
Okay.
It's at more work, yeah.
So this is the result of the analysis. Nowadays, more the goalkeepers are more prepared, especially the new upcoming ones. If it's the West Football, there's like Andre Belana, and then there's also Kepa and other. It's like sweeping keeper style. It's like they can help.
So traditional is better.
Traditional, who in the.
So traditional is better of fresh traffic.
Yes, traditional goalkeepers are in the saving prediction, not prediction, in the CSP that we we have found the safe range.
Model is preferred, so it's contract condition.
So the modern goalkeepers are preferred for teams, but traditional goalkeepers have been found to be better at saving
No,
shots.
I mean, yeah, be careful when we discuss the analysis based on the data that we got. The first one, okay, based on data, right?
Yes.
Because the saving shot. But the second one is really correct. This is based on data controlling the ball and most team are built. The most team are built upon information is not in the data, right?
No, but
yeah, be careful. You cannot put it. This assumption.
Okay.
Be careful.
This is the
Result to disability test.
In simple terms, the passes that was attempted and the passes that was completed, they don't really correlate with the distance because each passes can have varying distances. And that's it. Presentation. This is the example.
Most things you know, be a bit more careful.
More, yeah. The that's the whole week to fix the report. You please put more effort.
Yeah, maybe you constantly professional, the modern, and then forward. Just make sure not all features you need it, right? Just choose a feature that you need. And focus.
Okay.
Yes.
Thank you.
It's done.
So our report is due